So in the previous presentation, we saw an application of actually three technologies. Fluentd, it's an interoperable data collection system that's actually compatible with any standard you might know and was purchased by ARM. Then there was Vendelin, and the third component in that system is SlapOS. So it's an important component because very often people say that operating a big data infrastructure is too costly, except for very large cloud companies. So I've seen many large corporations, like one of the biggest oil industry in the world, that outsource their data lake or big data to some actually very big American company rather than doing it by themselves, because they are afraid it will be too difficult, but it's not. Actually, 100-person German medium business can operate their own data lake fully automatically by themselves. That's what we've just seen, and it's possible because of SlapOS. So the presentation will talk about the history of SlapOS, then how it's designed, what are the success cases, and the future. SlapOS was created around 2008, 2009, and was released in 2010 officially as probably one of the first commercial edge computing systems in the world. Many people understand edge with a different meaning. You might have a look at the presentation. You'll find more details about different possible meanings. Here, what we started with was by putting servers like this one in people's home. And after having servers in so many homes, we got a cloud operator that was fully decentralized. And, for example, we operated the whole system of Mitsubishi Russia for contract management on such small machines. There was one in Russia, because that's required by law, one backup in one country, probably in France, and a copy in Japan close to Fuji Mountain. And everything was operating as a whole decentralized system automatically. So before I keep on, I will try to relieve any frustrations from this talk. The first one, why aren't you using OpenStack? So if you know open source and cloud, maybe you know this word. Who knows OpenStack? Everybody knows. And why we don't use it? Because it doesn't work. And it will never work. Because its design at the core is flawed. It's imperative message passing architecture, not promise-based. And the result is that the system is unstable. So we've done some statistics. We purchased virtual machines from Rackspace, the initiator of OpenStack, from OVH, one of the 5 biggest hosting providers in the world. And we counted how many reboots per year we had of a Linux system. And on the left, we placed like this machine without UPS to internet in different offices we have in the world: Germany, Japan, France. And in average, a virtual machine on OpenStack will reboot between 2 and 4 times more often than a bare metal machine placed on standard electricity in Germany or Japan. In Japan, it will be exactly once a year, because they double check once a year all cables. In Germany, it's 0. And in France, in Paris, about twice a year, we have a small cut of electricity. So that's more reliable than a virtual machine with OpenStack. Now, why don't we use LXC, Docker, and containers? Who knows Docker? Okay. Because same, it's not really reliable. It's not portable across Linux distribution. You take an image from one system, you move it to another, and you might get strange errors. For example, do you know the command line free -h? Who knows? Okay? Sometimes you might get a negative value in a container. We had that. It means we have negative amount of memory. That's the kind of weirdness, if you're unlucky, that you might have. So it's okay for development, but for production system, it's unacceptable. You can read this paper. We explain in detail why we don't do that. So now, another reason it didn't exist really in 2008. And now, how did we design our system? First, we considered that everything is a service. A database is a service you connect to. A virtual machine is a service you connect to. A router that does daemon is a service. An ERP is a service. Once you understand that everything is a service, you understand that you can manage it in the same way. You want a database, SlapOS request MariaDB. You want a KVM, SlapOS request KVM. You want a routing daemon, SlapOS request resist. You want a CDN, SlapOS request CDN. It's the same concept. You request a service and you expect things to be automated afterwards. So the first step was, how can we unify service description no matter where, whether it's running on a smartphone, in a drone, in a data center, in a gateway. It should be the same way to describe it. No matter when, today or in 10 years, we want to be sure that the service we deploy, we can deploy it again in 10 years. No matter what database, VM, router, no matter which distribution, whether we use, let's have fun, Mandrake, or Ubuntu, or Debian, or Arch Linux, or Gentoo, or even BSD, we want our service to be portable from distribution to distribution, from POSIX to POSIX, and to be fully independent. No matter the version of the distribution, what is deployed in Debian 8 should be deployable in 9 in the same way with the same service descriptor, even if the Linux kernel changed. No matter the architecture, ARM, x86, RISC-V, no matter how complex, sometimes we have to deploy 40 mutually interconnected services that act as a kind of swarm of services. And it should support real-time, high performance, and be resilient to network shortage, electricity shortage, and all this for the lowest possible cost. That's the first design goal.